So welcome to the second panel, the EuCNC. So my name is Simone Redana. I am from Nokia Bell Labs, and I'm also chairing the 5GPP architecture working group as part of the 5GPP initiative that has organized the panel today. So just I want to introduce you what is the focus of the discussion in the panel today, which is 5G architecture. And the starting point, so the basis for the discussion today is also related to the white paper that the working group has just released. So it was released 1 month ago at the end of May during the first global 5G event in China. And we have had some discussion, and there will be an update of this white paper, let's say at the end of this conference. So you find here the links where you can download the material. But let's say the focus of this panel is aligned to what the white paper is focusing on. So which is the 5G architecture. So why we are looking at the 5G architecture and why 5G architecture is important. So one of the requirements of 5G, so everybody is talking about that, is that 5G needs to support a large variety of use cases. So this is a change compared to the previous generation. So when with 3G, 4G, they were focus on the MBB use case, largely focused to the MBB use case. With 5G, we want to design a solution that would enable to support also new use cases like automotive, the industrial. So we have seen various presentations also related to this in the first panel yesterday on the vertical. So I think it was good to have that panel before the one today. And to allow this, 5G architecture play a key role. So 5G architecture is what will allow the 5G design to be able to support the existing use cases, the use cases that we know we want to support, so as discussed yesterday, but also to be flexible and adaptable to support use cases that we don't know today, what are considered the unknown. So we want to be ready to support and to integrate use cases that are not known today. And for this, we want to design a solution which is future-proof. In the white paper, we have identified 5 enablers for this. So one is network slicing. As you will see, this is one of the key topics in the discussion today. So one is the support of end user and the operational services. Softwarization is definitely the basis for the 5G design, in particular for the 5G architecture design, and it has to be supported in a natively manner, so it has not to be extended, but it has to be supported natively. We need to extend the connectivity also, or the network, to not only support connectivity, but to also support the storage and the computation capability. So capability to deploy in different parts of the network computation and the storage resources. And then we need to support and integrate heterogeneous network. So of course we need to leverage from the existing or from the new radio technology. So we need to integrate the new 5G radio technology. We need to integrate into 5G the legacy, so LTE, Wi-Fi. We need to integrate the satellite communication. We need to, as I mentioned, integrate Wi-Fi, integrate the fixed network. So at the end, so we need to have an architectural design which allows basically to leverage from the existing and design solution for supporting the characteristics of new use cases which are not supported today by the legacy, like, for example, as we discussed yesterday in the panel, high reliability and the low latency. To address this, these are what we want to address in in the panel today. So we have 4 distinguished panelists, so which will contribute to the discussion today. So first, we will have a presentation from Konstantinos Chalkiotis. He joined Deutsche Telekom Group Technology in 2013 and is vice president of both the mobile access and the fixed network in Deutsche Telekom. And his primary function is to define the strategy, architecture, innovation in that area. Then he worked before in Cosmot, Greece, as a project leader for pilot and special projects in the new technologies section. So I think, okay, then we will have a presentation. The second presentation will be from Icaro da Silva. So Icaro is senior researcher at Ericsson in Stockholm since 2010. He's currently working as a 3GPP delegate in RAN2 working group for 5G related topics. In the recent years, Icaro has been driving both internal and external 5G architecture research work. He's a work package leader in the 5GPP project METIS2, responsible for the overall control plane design and architecture, and is active and has been active in the 5G architecture working group that has, let's say, issued the white paper that I was mentioning before. Then third presentation is from Dr. Alexandros Kaloxilos. So he's a professor at the Department of Informatics and Telecommunication at the University of Peloponnese in Greece, but he's also principal engineer at the Huawei Research, European Research Center in Munich, where he's currently head of the Radio Access Network Department. You didn't write it here, Alex, but you are also vice chairman of the 5GPP Architecture Working Group. Then last but not least, it's my pleasure also to have here also today. So he was also in the workshop on Monday on the architecture. So Professor Akihiro Nakao. So Professor Nakao received the PhD in computer science from Princeton University, and is currently professor in applied computer science at the University of Tokyo. And the Professor Nakao is also chairman of the Network Architecture Committee of 5G MF in Japan. They have also recently released a white paper on the 5G architecture, and he will present part of it during his presentation today. Okay, so now we move to the presentation from the distinguished panelists today. There will be between 6-7 minutes presentation from them, and then we will dedicate the rest of the time for discussion. So, Kostas, floor is yours. If you can load the presentation number 2, please. So this is the pointer, and up to you if you want to. Yeah, I think you need to.
Good afternoon. I will try to be short on this because 5G is a topic that we all want to have in front of us. The problem is that from the operator point of view, we're seen on a different aspect rather than the vendors and the universities and all the organizational bodies that are taking care of the research and development. What is 5G? 5G is the next generation because we invented LTE back in 2010, and now in 2020 we need to have a next generation of mobile communications. You know that every 10 years we're changing a generation. We started with GSM, then in 2010 we introduced 3G, in 2000 we introduced 3G, in 2010 we introduced LTE, and now in 2020 5G. This is the trend. I don't think so. We in Deutsche Telekom, we believe that the major driver is the user demands and behaviors, which is changing. This is the picture in the night of Easter in the street in Rome that leads to the St. Paul's Cathedral in Vatican. You see, this is back in 2005. This is the 3G era. And you see that only a few people here are using their terminals just to make some photos. Could you think how things have been changed within 8 years? Look at this. So you can imagine that the user profile and the user demands are dramatically changing. Changing so fast that the demands on the network side, on the capacity and the capabilities of the network, on the performance to upload on a live network, on a live transmission to the relatives, this is what's happening now in the Vatican, is huge, is enormous, and we cannot serve it with traditional networks. Back in 2014, globally, there were 7 billion devices, mainly human interactive devices. The forecast is that this number in 2022 will be grown by how much? Can you imagine? This will be 500 billion connected devices by 2022, meaning that we're getting out of the human devices and human interaction in the future, and we're going to everything connected. Everything will be connected. Each person will have 10 wearables. So we cannot handle this with a monolithic approach that our networks have today. Today, even with a single RAN networks on the radio side, we have a base station serving all technologies, but the capacity is not enough, and we cannot serve different radio interfaces in a consistent manner and with the capacity that we need. So what is 5G? Is it for digital life, for new business models, for the enhanced mobile broadband as the Asians want and Verizon in US, for tactile internet and massive Internet of Things, for vehicle type communications, for millimeter wave bands? I say everything of this is 5G. But mainly, 5G is a business-driven network. We in Deutsche Telekom, we don't wait for 5G to be in place. We are in the 5G era. We are front runners, and we lead it. We lead it. The NGMN white paper that has been published back in 2015. Bruno Jakob Feuerborn, our CTO, is the chairman of the board. We are actively participating, and back in February, when we had the Mobile World Congress in Barcelona, we demonstrated sub-millisecond latency live there with a robotic arm, comparing this with an LTE, with an excellent LTE latency that could not serve this, and of course the enhanced mobile broadband by achieving more than 70 gigabits. So 5G for us is not a future, it's here today. So we are working on this hardly. And having said that, I would like just to say that 5G for us is a business-oriented network. We will have some commodity hardware operating in different slices, and we will have different slices serving different business demands. This is the architectural view that we have, and we believe, and we are promoting this. On top of this, there is a question. After 5G, what? Will it be a 6G? Do you believe this? From the marketing point of view, it might be. But what is the difference? We are moving out from the monolithic approach and going to a commodity hardware that everything will be operating on top as a software function. Not only one software function, but multiple software functions serving different user demands. And of course, we will have modularity and functionality. Everything will be adaptable and interchangeable. And of course, we need the composition in the control and the user plane in order to serve the user demands. And we need also, on top of this, coordination and adequate transport requirements. This is our view. Coming to the radio, which is my favorite topic, I would say that initially we thought that 5G will be a radical change. Yeah, we need next generation interface. We will not believe backwards compatibility, which is now not the reality. Following WRC 2015, the new frequencies that are clean, and we are expecting to have the next generation interfaces, are in study items, has been allocated above 24 gigahertz. Can you imagine a network that provides unique coverage operating at 28 or 36 gigahertz, providing also indoor coverage? So we believe that there will be next generation air interface for sure, starting in higher frequencies, but the basis for 5G will be, for 5G services, will be the air interface that we have today on LTE Advanced Pro that will start below 6 gigahertz, and gradually we will have dual connectivity and moving to the next generation air interface after 2025. There was an agreement 2 weeks ago what will be in release 14 and 15. Release 15 will be the first release of 5G. There was a decision to go a little bit faster. The next generation air interface will be ready in the middle of 2018. And then we will have the full-fledged of 5G next generation air interface at the end of 2019, when we will have the first commercial deployment of the next generation core network. What we believe on the end-to-end architecture. We need a new core network, yes. We need gradually to integrate the existing air interfaces to the 5G services. And on top of this, we need to develop new air interfaces that will be capable to serve the demands of the users. And by saying this, I would just like to state that 5G slices are already in place today. Have you heard about narrowband IoT? Narrowband IoT is a technology that can serve massively sensor-type communications, having a capacity of 50,000 sensors per cell, that is here today, and it's developed, and in the coming months, it will be commercially available. And having said that, I would like to thank you for your attention.
So thank you. Thank you, Kostas. So let's move now to the next. So Icaro, if you can load the number 2, please. Okay. Floor is yours.
Thank you, Simone, for the invitation, first of all. It's certainly not a big effort to be here at the end of June to talk about such an interesting topic, right? How do I move the slides? No, it's not me, but it will be me in few days. So it's an inspiration. Can we move the slides, or shall I do it? Ah, I can use this, right? Okay. When I was preparing this presentation, I was asked 3 questions, and this is what the presentation is based on. So the first question was, what are the architecture design principles and building blocks that you are working on for the 5G era? And I first of all tried to respond from an Ericsson perspective. So I work at Ericsson as a senior researcher. And I could think about that Ericsson has led the METIS project, which laid the foundation for 5G. And basically we developed together with all the partners all use cases and the first technology building blocks, trying to understand how they could meet the 5G requirements that we kind of developed. But then we moved to METIS 2, which we're also leading, where we talk about this overall 5G RAN design, where we go one step further and trying to understand how these technology components, they fit together and what would need to be standardized in order to support those requirements. And we continue this story, of course, as one of the leaders in the 5G standardization in 3GPP. And here I basically mentioned 2 aspects related to architecture, but basically the mobile network architecture. And one is, of course, the new radio and the evolution of LTE to address massive MTC, XMBB, and ultra-reliable and low latency communication. But also the next generation core network, which has some principles, partially, of course, studied by NGNM requirements that should be NFV friendly. We should have even more softwareization. We talk about a lot of soft networks, right? But our networks today, they are partially made on software. There's a lot of software there as well. So it's not something completely new or completely revolutionizing that there will only be software. We have a lot of software. We are a software company. But there's also UPCP splits or UPCP separation, kind of SDN kind of point of view or inspiration. Full support for end-to-end network slicing, but also prepared to serve multiple industry. And that was the slicing view when we launched let's say, first white papers when you talk about network slicing for the core network. But then I also interpret the question about myself, like what am I working on? And now I'm Ericsson delegate in 3GPP, driving 5G architecture topics. And here I just mentioned a few topics. Some of these are topics for today, but also have been topics in previous talks in a paper I presented. Basically tight interworking with LTE. Like I've heard a couple of times, this is my preferred topic, but I worked quite a lot with that. Standalone 5G mobility and initial access, everything that is related to beamforming and beam-based procedures like beam sweeping, measurements, reporting, this concept of having a cell or not having a cell. Now it's a strong debate in 3GPP, I should say in Run 2. I was driving that as well from an Ericsson perspective. And I recently moved out of Metis 2. I was leading the overall control plane design, and I was also an active contributor to the 5G PPP architecture working group. And last but not least, I'm very enthusiastic when it comes to this area, and sometimes this can become some heated debates, I guess. Some people who work with me are kind of used to that. Let's see what will happen today. So the second question was, what are the implementation aspects for the above principles and building blocks? And then I twisted the question around, because to me that's not, let's say, the question I would like to answer, but I would rather say that anything that the connected society needs has to be implementable, which basically means that the standard architecture must be flexible enough. But what does it mean to have a flexible enough standard architecture? Basically here I'm referring to the current status on the 5G architecture in 3GPP that we're working on. So basically the 5G mobile architecture is now called next generation architecture, and it's comprised by two parts. One is the next generation RAN, and that's comprised by LTE and the new radio, and the next generation core network. So the first thing to take into account here is that this is the first time that the next generation RAN comprises as well the evolution of the previous generation. So LTE in 3GPP, or the LTE evolution, or whatever we want to call it, LTE Pro, maybe they will find out another name later, is part of the 5G RAN architecture. And here on the left-hand side, I show the figure that we currently have in SA2 for this reference architecture with the UE, the next generation RAN comprised by the two RATs, but also the next generation core network and some of the interfaces. And this is what we see here as well. And the first thing to think about is like we have these two RATs, and this is some terminology. And here I put just some interesting phrase, say like, please don't call me 4G++. Nothing against the 4G architecture. I've heard this morning that it was well done, and you can achieve quite a lot of things with that. But it's a kind of simplicity view, showing that simplicity doesn't necessarily mean that it's not good. It's actually very beautiful. It was an evolution from 3G to 4G, and it has a lot that we can achieve with that. And here are some new characteristics that are being considered now, not only from our perspective, but from a 3GPP perspective. So we have to support the different use cases and fulfill all the requirements. This is the basic thing. This is a must. Some of these could be already fulfilled by the LTE evolution. Some of these will need the new radio, and they have to work together into this new architecture. We want a common core network that has to be connected to both RATs as well. This is a recent progress in SA2 and also Run 3, that we will have an interface connected to both RATs for the new core network. We also like to have a common core RAN interface, and there are some benefits, and even in Metis 2 we studied a lot of those benefits, and now this is becoming reality in 3GPP. We also want an optimized state transition without, let's say, core network signaling, so that basically means that we want some sort of inactive state where the UE can move across without notifying the network if I'm moving from LTE to the new radio. So this reduces a lot the signaling. We also want dual connectivity between LTE and the new radio. I guess this is currently one of the hottest topics in 3GPP. But in addition to that, we also want something that 3GPP calls high-performing mobility, which is basically a RAN-based mobility. So you can do handovers between the two RATs in the same way you do handovers today between LTE cells. And this is thanks partially to this common core network interface, but also thanks to this, let's say, X2-like interface, if you want. So tight interworking, you probably heard this term a couple of times. So tight interworking is not the same as dual connectivity. This is typically a kind of misconception. So tight interworking is let's say, kind of this figure. And what you can achieve with this figure is a certain number of features. One is dual connectivity, the other one is inter-RAT RAM-based handovers. Last but not least, so this is a starting point architecture, which is some sort of simple, logical, standard architecture, allowing a high flexibility with regards to deployments of functions. And this is basically what you can do with this standard architecture in terms of implementation. You can distribute, you can virtualize some functions, you can centralize some, you can optimize hardware and place in the different locations and all these kind of things that some projects are also studying. To wrap up, the last question was, what is the standardization roadmap? I guess when it comes to roadmap, 3GPP has more or less defined some milestones. I'm not going to talk about this, but I prefer to select one specific interesting topic, which to me is a big challenge. So now we talk about this early standard drop in 3GPP, where NR is connected to LTE via the EPC, while the next generation core network is being designed. So these works, they will happen in parallel, but 3GPP is going to work on something like that, right? So basically we have S1 star, potentially with some changes needed. But this is basically EPC. And here you have LTE, and then you have NR non-standalone, as we call. And basically non-standalone means that you don't necessarily have the full functionality over NR. So if you want to do initial access, for example, you would do it over LTE. You read system information, you synchronize, you do everything as you do it today, but you can add a secondary carrier or a secondary lag over the new radio in those frequencies. So this is this early drops, and this requires basically some changes into the LTE or RC design in order to support some of the functionalities needed, like measurements, reports, and some RC establishment, reconfigurations, and so on. But then you have the target architecture here, which looks very similar except for the colors and maybe some letters, right? But basically, the target architecture has a next generation core network, but we also have both RATs. So this is the first important aspect. So this is not something that is dead end, but it's something that we have to connect to the next generation core network as well. And we also have this interface, and you have new interfaces here. So this is the target 4G, or sorry, this is the target 5G mobile network architecture, and this is the early drop into 3GPP. The question is, what is the migration story? What is going to happen in between? And I guess you explained that there has to be some sort of migration where slowly we move from this scenario to that scenario, and the question is, what is this? And basically, 3GPP has to work out on this. This is an ongoing discussion, very interesting. There are many technical challenges to think about. But basically, my takeaway from that is that it would be very good, if not extremely necessary, to avoid the creation of parallel tracks, which is, I typically say that it's bad for everyone. I mean, it creates a lot of extra work without solving necessarily a new problem. And that has associated to it cost, like you don't speed up innovation because you need to put resources in both tracks, and so on and so on. So this is, to me, the biggest challenge for the network architecture for the next few months, I would say. Thank you.
So thank you, Icaro. Alex? So now we see the view of another vendor from Huawei.
Thanks, Simona. Thanks for the invitation. Yeah. And let me start by saying that I consider myself very lucky working for Huawei RC for the 5G topic for two reasons. The first one is that I can have the chance to participate in such a panel and visit back home. The second one is that in Huawei ERC in Munich, we are doing a lot of things and we are covering a lot of ground in the different domains, from the physical layer to the core network. And we are also heavily participating in a number of European projects, so we are doing our best to help Europe in the research efforts to achieve results and achieve the final target, which is the 5G. So, as Icaro was mentioning before, we received 3 questions from Simona, very good ones, to summarize what we have in mind and what we are doing. So the first one is with what we are involved with. And as you see, I have selected these topics. The first one of the hottest topics is the end-to-end slicing. And you already heard this term being referred. as you see in my slides, I'm trying to have some technical topics. So what is end-to-end slicing? Of course, it's business-driven, but we have to identify and come up with solutions for a number of specific things, like what is slice isolation? Can we put all the different business slices together? Can they affect each other? Is there going to be a problem about this? If we isolate them, to which level we can isolate them? Can we multiplex the resources? How can we do this? Or other topics like having one terminal being connected to multiple slices. How this will affect the implementation of the UE? And what is the implication on the core network? And can we take this into consideration to help us improve the control functions on the core network side if you have terminals being connected at the same time to multiple slices? Can we share functions, protocols between the different slices? That's another interesting question. If you deploy multiple slices, do you need to cater for inter-slice management or not? And what exactly does it mean? And how we can have dynamic slice configuration, adaptation, and management. Because one of the targets is that we want to offer new businesses, we want to minimize the deployment of new services for the customers, etc. Then we go to the physical layer aspects. You've seen that there is a lot of work in European projects about the harmonized air interface, the waveforms, or the numerology and the frame structure, modulation, coding. And there are projects discussing these things like Fantastic 5G, where we participate. Also, there's a lot of work about harmonization in METIS2, where we also participate. And if we go above 6G, there are solutions for millimeter waves, like Millimeter Magic, where Huawei ERC is also participating. Then we go to the RAN aspects. That's actually my domain. It's a very interesting, I think, topic. We're going to see new air interface variances. What is an air interface variance? We need to consider the whole protocol stack. And we need to identify if the different air interface variances for the different verticals require new modifications in existing protocols. And if they indeed require new modifications, like how to achieve 1 millisecond delay or 5 nines in reliability, because today protocols, they cannot achieve this. So if we have specific KPIs for the verticals, we have to come up with the solutions. And this requires to modify the protocols. And we have to identify to which level. Our team also considered one of the most challenging use cases for 5G is V2X, because it seems that the automotive industry is going towards this direction about autonomous driving, and they need to find a solution about how to communicate between the cars, with pedestrians, with infrastructure, and ultra-reliable communication means 1 millisecond delay, for example, and 5 nines in reliability. And we have to redesign several protocols and think out of the box and come up with some new solutions. Also, we need to revisit RRM, especially if we deploy multiple logical networks, and see how we can offer quality of service and prioritize between the different services. One of the hottest topics right now, even in 3GPP, is how to improve the quality of service in the RAN domain. Now, moving on, we have work being done in the transport network. There is a very nice and interesting project, which is the 5G X-Hall, trying to have some SDN principles in the transport part of the network, and separate control plane, user plane, because we can adopt some of the SDN principle and introduce some new controllers and a new infrastructure and, a framework for the architecture for the transport domain. And discuss also about edge clouds. Moving on to a project that I really like, which is the config project, and I really like it because it's a good proof that if the ideas are very good, you get commitment from the partners, even if you don't always get the funding. So there are partners and in the front line working very hard for this project, for the core network, because I think that this has been brought up already. The core network has to change, and we have to see how to change the core network. And this is a project about the core network. So it discusses new topics like modularization of the protocols, how these protocols are going to interact with each other, how mobility management is going to take place, session management, the policy enforcement, traffic steering, all these nice things we have to revisit. Why? Because we have different verticals, and different verticals have different requirements. For example, some verticals require connectionless mode of operation. And of course, this is the playground especially for the SDN and NFV principles, full virtualization. As you have seen, there are the different domains, access, transport, core, and then we have cross-domain. So if we change the functionalities in the core network, and we change some of the functionalities in the access, or even if we decide to move some of the core network functionalities to the access, how is this going to be done? How the interface between the core network and the access network is going to change? How we can achieve with the context awareness, for example, data analytics is another buzzword. Can we use it in order to improve the control plane functions and offer to the operators some new advantages? And of course, in 5GX, we have some work. As I said before, in all these projects, we are participating from Huawei ERC. 5GX is about cross-domain and multi-operator orchestration and coordination about the deployment of the function and the offering of slicing opportunities. So this is the first question, what we have been doing for 5G. 5G is a huge area and we have to do a lot of things. The second question was, what are the implementation aspects for the above principles and building blocks? I understood this question in the following way. I really like this question. And I have to say the following. Of course, in the past 3-4 years, we have been discussing about 5G. And there is a hype and a lot of buzzwords. And I think somehow it is the time that we have to find exactly what is the meat. And we have to see if some of the things that we are proposing really make sense or are simply buzzwords, and even LTE with some tweaking can offer the required KPIs. So there are things like, as the previous presenters discussed, is, okay, what are we going to do with the LTE, the interworking, the core network, the different interfaces, how we are going to support, deploy and support the slices, and how we can support natively the cloud infrastructure. You know, it's very difficult to go end-to-end in the network from the UE to the PGW and spend hundreds of milliseconds when you really need tenths of milliseconds. So we have to revisit some things. We have to identify from the applications, from the verticals, what we have to transfer closer to the edge so as to achieve the required delay in the user plane, for example. And of course, there is another topic, which is the following. Slices is about logical networks. We can deploy with slices multiple logical networks. Then probably we have to revisit network management, because we have to manage in an automated way and very in a trusted way also, network management of these multiple networks by a single event operator. And finally, what is the roadmap? I think that there are other people that are more, let's say, experts than I am about the roadmap in standardization. I see several people in the crowd that are going to the meetings and they know better, but there is a lot of work being done in standardization these days. The work is picking up a lot. In every meeting, I know that they are treating many proposals from the different companies, and they are doing an excellent work. However, because exactly the scope of 5G is quite huge, there are many things that they have to solve. And as you know, there are 2 phases. We have to see how many things are going to be covered in the first phase and what will remain for the second phase. There are topics from SA2, I just picked a few of them. There is a higher priority for example, for slicing, the quality of service framework, and session management, and there are some other things with lower priority that also are important, but they cannot treat everything at the same time, like, for example, the support for relays. Similar things in run 2 and 3, tight interworking, as Ikar was saying before, is one of the most important things. Also, I have to agree with him on this. And the different deployment scenarios, what is slicing in the run? You know, this is a big discussion, and Simone is already prepared to open this discussion later on. What is slicing in the core network? What is slicing in the run? Because we say end-to-end slice, but is it really the same thing in the core and the access to discuss about slicing? Or is it something different? And I think the different companies have different views on this. It's still unclear. And in run 1, there is a big progress in numerology, frame structure, and there is an evaluation ongoing on the base technologies. And with this, I also have covered my presentation. Thanks a lot for your...
So Thank you, Alex. Last but not least, so Professor Nakao. So if you, okay, presentation is ready, so floor is yours.
Thank you for introduction. I'm Aki Nakao from the University of Tokyo. So I'm an exception in two aspects. One, I'm from academia. All the other people, panelists from industry. I used to work in industry, but I hate to work for my boss. I switched to academia. And second, I'm not part of 5G PPP. We have a 5G mobile promotion forum. So, Simone, told me that I have only 6 minutes, but let me start with this slide. So this slide makes me a little worried because every country has a promotion forum, and also 5G PPP is a huge project. But if we have different views, every country, it's a problem because we have to converge. That's why we have to work on the standardization. And that's why I think I'm here to deliver this talk. We started this 5G MF in 2014, the last one that among these all. But we try to run as fast as we can to catch up with you and try to define what is 5G and what the key technologies. So this is the organization of our 5G mobile promotion forum. And we have General Assembly on top, and we have 4 committees, and a strategy planning, technical committee, service and application committee, and a network architecture committee, and which the last one that I'm chairing now. And when I saw this structure shown by ministry, I didn't like this structure very much. Why? The technical committee is dealing with the wireless technology. And network architecture needs to think about both the wired and the wireless technology. But wireless people used to think that they can take over the world, and then that doesn't talk much to the wired people. So I hate these boxes separated. So we decided to talk to each other, and in our organization we are meeting every month. The network architecture committee and technical committee. Talking about converged network architecture and what is necessary for 5G mobile network. And also I would like to stress that we have an application committee. So application needs to drive the infrastructure design. We believe in that very strongly. So we think about a 5G application first, and then we drive the design of the these wireless and converged architecture. Okay, so these are the members. There are 93 industry members, and we have individual members, 14, and MIC, ARIB, and TTC are 3 special members. Okay, so this is one thing that I wanted to deliver today, and also this is question. There are 3 questions that Simone asked me, and previous speakers already answered from their aspects. But what are the architecture design principles and building blocks you're working on for 5G era? So this is exactly what we started discussion on in our joint committees between the wireless and the network architecture group. And we wanted to deliver very simple messages to people, to the taxpayers, okay? So there are 2 5G concept, satisfaction of end-to-end quality, and the realization of systems with extreme flexibility. So first we talked about flexibility, but I'm willing to put extreme because it's not just flexibility. We want the extreme flexibility. I'm telling you why we want to put extreme later. And the 2 5G key technology, advanced heterogeneous network, and network softwareization and slicing. So previous speakers already talked about network slicing, but what we are thinking about network slicing is slightly different from what other people are thinking, I guess. So I want to stress that as well. So first I want to talk about two key concepts. Concept is a little bit ambiguous terminologies. These are the two goals that we want to achieve, and we want to tell people, non-tech people, they need to understand what is coming for a 5G mobile network. Satisfaction of end-to-end quality. End-to-end quality is the most important for our users. So yesterday, I was driving to, all my friends all together went to Sunio, the very nice place, and we took nice pictures there. On our way back to our hotel, we were talking about sharing all these great pictures, right? But we have to go through the mobile, mobile router, and then going through, whatever operators, and we are within the cars. Right? We could broadcast our pictures and share instantly, but and in instantly means that we don't have to have a very long haul connection to share our pictures. We need to give users satisfaction of end-to-end quality, right? And this is very different from the previous generation. Right now we have to go through operators, but we should be able to use whatever technology that is available there. And extreme flexibility is that to produce the level of end-to-end quality for many services, individual application, it has a very different requirements. We need to support with a single infrastructure. So there we drive this, the wireless part, we need to have heterogeneous networks. We need to combine various 5G radio access technologies and already existing 2G, 3G, LTE, and wireless LAN technologies. For example, I gave an example of sharing pictures, but we should be able to combine all these technologies to give the users a satisfaction. And a network softwarization and slicing. We need to be able to use a single infrastructure in a different way with isolated resources to provide a stringent QoS requirement for various type of applications. So these are the two these slides. So this is very simple messages. We want to deliver to especially users what 5G mobile networks is, and what are the implementation aspects for the above principle and building blocks. We came up with this picture. So we think that application is on the top, and we have various latency requirement, data rate, and the mobile devices, and even more. But in order to support that, so at the very background, we need to have a softwarization technologies. We need to be able to flexibly program the infrastructure. And the reason why we said the network slicing that we are attacking is slightly different is that deep programmability or application-driven thinking and information-centric networking and ultra latency. So all these small bullets that we listed here are involved in network softwarization. And all these ideas will support management orchestration, which includes automation, autonomy, intelligent. So not much concept is including this intelligence and automation and autonomy part, and the knowledge is important. And the mobile edge computing and front hole, back hole slicing idea. So these are the 4 focus areas that we think that is important. And we, draw this diagram. This again, we intentionally made it very simple to deliver the 2 key messages here. So in order to support various types of applications, we should be able to create slices end-to-end from UE, RAN, mobile packet core, transport, and cloud. So then for individual type of application, we should be able to create slices. So people always talk about verticals, right? And I don't quite like, maybe we should start calling horizontals, because we are creating slices end-to-end. So this is actually translating from a vertical to horizontal. We are actually meaning that each vertical can be fit into each slice horizontally, end to end. Okay, so different type of resources can be isolated in a slice A, slice B, slice C, and then end to end communication is guaranteed. And a physical infrastructure, the computation and storage. Number 2 concept is that the computation and storage resources are embedded end to end. So if you want to use a mobile edge computing, so then you have to use the computation and storage here. But there are lots of people talking about the cost. So if you use the edge computation, so you have to have many computation resources. So it's costly. So you have to find sweet spot along the end-to-end path where exactly you should embed a computation and storage. So finally, the last question was a standardization roadmap, and I don't have to repeat, with previous speakers. 3GPP is certainly playing a very important role, and our industry members are pushing this standardization activities. And also ITU, so not many speakers today talked about ITU, but ITU-T has a focus group which is analyzing the SDO's gaps, which SDO is covering what, including DISU and the DFACT, ETSI and also ONF, related to SDN and NFV softwarization technologies. And these are the events that we plan to do domestically. But in the end, so right now we publish the white paper, but we would like to collocate events with all these standardization activities. Okay. And briefly talking about ITU-T focus group, many of the folks in the 5GPP group have already contributed to this focus group. Now we are doing a phase 2. We have done a gap analysis, but now we are doing network softwarization as a key group. In fact, we scheduled a meeting which coincides with this panel discussion where I couldn't attend this one, but I'm leading the network softwarization group, and mainly we are talking about network slicing. So if you are interested, we define the network softwarization in this group, and also we have we have done lots of analysis, and also we are analyzing other SDO's activities. And recently we think that slicing in the area of this mobile front haul and back haul, this is the very important issue if you want to create end-to-end slicing, network slicing. So thank you very much. This ends my presentation.
Okay, thank you to the panelists for the presentation. Good. So I want now to move to the panel discussion. So I have captured few points here which represent along the presentation that when I was scrolling through the presentation from the panelists. So the end-to-end network slicing, I think it has been touched in few presentations today. I think this could be good that we enter more into the discussion of this topic. Another topic is that 5G is based on virtual network function, so softwarization is a key enabler. Then 5G core, looking more towards an evolution of the EPC, so an evolution of the 4G architecture. So this has been also touched in previous presentation, or we need really a new disruptive core network design. We look at the standardization, so what are the happening in standardization, but also 5G is already today, so as Kostas was mentioning, so is already happening now. So I want to open the floor to question from the room. Feel free to ask questions, also that are not related to this topic. So we can also have a part of the discussion which can go also in other touching other topics if you think that is interest for the discussion today. So first is related to the network slicing. So network slicing has been touched in few presentations today. So maybe what we can start, maybe some comments from the panelists. So we have seen yesterday presentation related to the verticals. So how we can support the verticals. So I introduced at the beginning that architecture is a key enabler to support the verticals. So how can we achieve this? So how can the network slicing help to support the vertical? So network slicing is in a solution there. And do we need a slice per vertical? So I think this was also touched in one of the previous presentations. And do we need a network per vertical? So a slice can create an isolated network. Do we need really a network per vertical? So maybe we can start if any of, shall we just start from you, Kostas? And then we can take also comments from the audience.
To be honest, I would prefer to have an open discussion with the audience, but in any case, when we are speaking about verticals, I already declared that 5G is a business-driven network. So the business demand should be served by a slice, not a separate slice per vertical, but the same request should be served by the same slice over a software. In our opinion, all the 5G concept should be move out from the monolithic era that we are today and move to a standard hardware that can operate software-wise, virtualized, or with an open architecture to serve every different demand. Shortly, this is from my side.
Is there any, maybe is there any question related to this topic?
Thank you very much. My name is Anastasios Gavros from EuCNC2016. I have a question basically to all four of you with respect to the granularity of slices. Because if I read the question there, do we need a slice per vertical? We have seen requirements from verticals that are very divergent in themselves. So if I talk to the health industry, they really cover basically the full range. So perhaps very similar question. How many slices do you think we will have in the network? I don't want a very precise number. I want only the order of magnitude. Are the 10,000, 100,000, or even more, or millions?
Icaro?
Maybe we can try to address the question. I guess there are a few misconceptions about the term slicing. That's the first thing to think about. First thing is slicing is not a technology. Slicing is more an abstract concept. Slicing is not NFV, is not SDN. SDN and FV, they are technologies that can be used to create those logical networks. So this is the first thing that I like to highlight. Second thing is that there's no, let's say, one-to-one mapping between slicing and service, in my opinion. Slicing is more a business-driven, let's say, operation for this logical network. And that logical network can actually have multiple services, can be one service. And this is a bit the difference between slices and what 3GPP calls a slice instance. So if you say like how many slices, there could be many slices instances, as many as, let's say, the infrastructure owner wants to create in order to, let's say, supply the verticals. And then some of these slices, they could be similar to each other because they don't need to be different. Some of them, they will be different. There could be different configurations and so on and so on. And there has to be some standard support, some functionalities in order to address the different requirements. But it's very important to make this difference between slice and slice instance. And also remember that the fact that we need to address vertical ABC doesn't mean that we will have slice ABC. There could be one slice with multiple services, for example. Or there could be multiple slice instances that, from a technical point of view, they are addressing the same kind of service. It's a business-driven thing. It's more a business purpose network.
These are indeed interesting questions, and I don't think that any of us has a fully clear answer at this point. It's fully debated in standardization in the projects. We have a lot of discussions. In our view, for the slicing, we have to distinguish a few things. I fully agree that this is a business-driven concept, and we have the different instances. So if we want to separate, for example, that for one slice, one client needs to have different security settings, different policies that have to be enforced, then on a software level, we can distinguish between the two slice instances or slices, you can call it how you like. This is fully applicable for the core network. For the access network, we see that this is somehow different for some reasons. First of all, we don't think that you can go for full virtualization in the RAN. There are some real-time functions, synchronous, we call them in Metis, which are on the lower layers, and these are very tightly integrated with the hardware. So this cannot be easily virtualized. At least there are no, let's say, final concrete results that we can virtualize physical layer functions and achieve the requirements that are imposed on them. The second thing is, we were doing an exercise. Many of these things are related to the use cases and the verticals. So we went out to the first Metis project, which is a nice compilation of use cases. We found out, okay, we have 21, 25 different use cases. How different they are between them. We ended up that essentially based on mobility, throughput, user density, reliability, coverage, we can have roughly 10. So in the RAN, we see that we can have something like 10 different configuration modes. So essentially, for the RAN, we see that we can multiplex a number of slice instances from the core to a specific number of configuration modes of the RAN. So that's another answer, more technical, and I hope I shed some light.
So we could talk about a definition of slicing for probably longer than 2 hours today. But so the slicing is creating a great confusion. And but let me briefly, define in the following, because in the research community, we define a slice as an isolated set of resources, including network bandwidth and computational resources and storage resources. So if you think of this way, I'm not saying that the other definition is wrong, but we have been working on the definition of slicing for more than 10 years, and there we define a slice as a set of resources, and whatever function that we realize for business purpose, we use these resources to program these resources and they realize these functions. So the 3GPP definition is not really, far away from what we have defined in the research community. So I want to respect both definitions. So, I don't want to create a fighting between, these two communities. But having said that, let's think for a while and take it that slice is isolated resources. You can program and you can implement the functions. Getting back to Anastasia's question, how many slices we should be creating for businesses? One per vertical, right? Or one per device, one per application. We recently, had a project per application slice. It's a very interesting idea. So if you have a smartphones, you create, individual application, you create one slice. So this is just a matter of how much resource you want to isolate it for device or application. If you have tons of applications, then you want to separate them, and you can apply separate functions. So then you can create. You should be able to create tons of the same as the number of applications. And we recently tried this in the University of Tokyo. We hand out smartphones to students, and we create a per application slice, because lots of vendors, lots of operators are now try to apply application-specific functions like caching or QoS definition. And I think it's not only true in Japan that operator is suffering from the smartphones OS upgrade. So if iPhones is updating, Android phones, OS is upgrading. So it's a network upgrade. And it happens at the same time, it kills the bandwidth of network operators. And there are many suffering, people suffering from this problem. So if you could create a slice for OS upgrade application and apply a caching using storage, computation, it's not just a matter of QoS. We are using an isolated set of resources applied to this particular application. So getting back to your question, quick answer is that it depends on what you want to do with the slice. If you want to do application-specific resource usage, so then you have to have as the same number of slices as applications. If you want to do this for device, your device, my device, you should be able to create per device slices. If it is vertical, in the same number of the verticals. So, I don't want to sound like I'm, avoiding the answer, but I think this is true. You have to have application use case, or apply application of the technology, and then you get answers, I think.
Any other question or comment related to this topic, Alex?
It appears to me from a distance that 3 out of 4 members of the panel agrees that the differentiation is in the use of the slices for business, for programmability of the functions, also in terms of being a partition of more than just connectivity resources, but include computation and storage and bringing them together. Compared with one, which basically believes that it's only the connectivity resources with no view about how to use it for services, for management. So, because it's so fundamental now, does it mean, and this is a question for Ikaros, because he's the odd one out, as far as I can see, does it mean that whatever architecture you are proposing is going to be obsolete in a matter of a few weeks? Because it needs to be updated, how slices and other things which do not recognize only it goes well beyond the borders of the runs and core. They go for the service networks, the management, the computational, and also edge networks, which are clearly becoming more and more powerful, where more functions will come. So does it mean that are you confident that the architecture you are dreaming of is not going to be obsolete in a matter of a few days? On the other hand, I have a question for the rest of the panel, which is a bit more complicated. Everybody said that this architecture has to link the dots of the known elements. But we hope that this architecture should link the dots of the unknown elements. Question is, what are these unknown yet elements which still has to be explicitly formulated in the architecture? That's the second question to the whole panel.
Thank you, Alex. So I think, Icaro, you want to take the first one, right?
I'll try. I didn't fully understand the whole detail of your question, but I probably can understand based on our previous discussions on the same topic. I will try to answer that way. So it doesn't work. So we want to repeat the question, or?
Yeah, but I think you should. Okay.
I can try. Yeah. If I don't respond,
think you know what Alex is asking, right?
Yeah. I guess the first thing that we need to think about here is that, and this was the same discussions we have had in this architecture working group. One thing is what we standardize, and one thing is what we build based on what we standardize. The standardization is a mere practicality that works, let's say, based on the way the ecosystem in our industry works. The reason we go for standardization is because we want to have an ecosystem where multiple companies should provide different products and they should work together. And this is why we standardize interface, this is why we standardize protocols, and so on. Otherwise, a single company comes and sells everything, the whole equipment, core, transport, devices, and radio, and antennas to an operator. But that's not the way the industry works. The industry works through standards, and that's what we do. And there's a trade-off in standards between the amount of work we develop there and the solutions we provide. and the complexity that it brings. It takes a lot of time to standardize a very single feature, and it's really a lot of work. I mean, sometimes we draw boxes and arrows, but really to standardize something takes a lot of effort, and it's very, very hard. So basically, that's why we try to come up with a compromise thing that is simple, address the needs in terms of the services, but also address the needs of the operators in terms of having, let's say, a multi-vendor ecosystem. And then on the top of that, what you can do in terms of implementation, and I think most of our 5G PPP projects, they are actually working on implementation aspects. It's a lot. It's a lot you can do. And less you do in terms of making this very complicated, easier is to make things when you go to the implementation, which is the real thing that you build. So when you see a simplified architecture like this, and you say it can become obsolete, I say it's the opposite. This proves that the 4G architecture was quite, or let's say the 4G architecture moving from 3G to 4G had many good aspects. And the proof that in 5G, we have somehow think about a similar baseline, at least some aspects. There are many other new aspects that will change in the core, and maybe the split is not necessarily the same. But many aspects were good and were kept. And this is the reason we keep, because it was good. We don't change things that are good. This is a bit the principle when you go for standards. But this doesn't forbid you at all to build something very flexible. And I think we are going to build some things very flexible. All the other vendors also envision to build some things very flexible. So the problem is a conceptual problem, that there is a misunderstanding on what is standardized and what can be implemented. So this is the short version of my answer. I hope I addressed the comment.
Yeah, Alex?
Well, I think that both Alex and Nicaro have a good point. I mean, even in 3GPP, there is a requirement for future compatibility. So we wouldn't like to change the standards again in 6G or 7G. On the other hand, we have to be realistic and practical. Otherwise, nothing is going to be implemented. So I think this brings out the following point. I mean, we need to be flexible in deploying functions, but also we have to be very careful with the interfaces. So we have to find an elegant solution on how to achieve this, which sounds to be like, an impossible task, but this is one challenge that is quite real, and we have to face it.
You want to add?
Yes, may I add one thing? First of all, the standardization is not in place to create the ecosystem. The standardization is in place, based on 3GPP and other standardization bodies, to create the size, to give a global footprint. If we leave the things as they are, we will see a fragmentation. And this is something that we don't want, and we must avoid. Fragmentation on a global manner means that we're ending up with in the era that we're using different phones when we're moving around the world. This is something that is unnecessary, and it will create a huge fragmentation, which is not the case. Of course, things will be standardized, and I have to disagree with the vendors, because in our opinion, a lot of things will change radically. When we're speaking about radio, and I heard earlier that Huawei believes that virtualization in RAN is not feasible, I could invite them to our labs in Bonn to demonstrate them how a base station is operating in a virtualized environment, using standard quartz hardware, by splitting the functions, the layers, layer 1 and layer 2, and you can see it operating. What I say is that we're moving out from this era. We need to change, and we know this. Otherwise, we cannot serve the demands of the future, and we need to change the network every 3 months because the capacity is not enough. This is not the scope for us. Thank you.
I tended to speak a lot, so very brief. So I'm agreeing with this view that, so we used to think that the technology is very complex and hard to achieve, but now we are moving very fast. And for example, when the VMware came out, we think that server virtualization is not there. It's very slow. And I remember, 10 years ago, it's not usable at all. But then, we polished this technology a lot, and now, the cloud data center all runs VMs there. So you might, this is academia's role. You have to propose a radical and crazy idea, and craziness is your complement in academia. And we think that the network slicing is the craziest idea for most industry people, but now it's taking off in the 3GPP. And if you show people that this is a very good concept, and if you could realize with the low cost, people buy it. But the important thing is that you have to show the benefit or values of network slicing. So that's the role of the industry, and industry, academia can propose conceptually it's a good idea, and it's a complex at the first glance. But then, if the industry picks up this idea, try to define a simple and cost-effective solution, and show the benefits, so people start jumping on it, and then doing the standardization.
I think realizing the network slicing in a cost-efficient way is the key here. Alex, I think you want to comment about Huawei comment.
Huawei was brought up. First of all, thanks a lot for the invitation, which I gladly accept. It's a good thing. Thank you very much. Actually, it's very difficult in a panel discussion in a few minutes to fully disclose what you have in mind. So I think that we need to consider that there are different deployment cases. Sometimes when the backhaul is not ideal, and functional deployment is under investigation in several projects, and there are some advantages and drawbacks. So I take your argument and accept the invitation, and I think this is a topic for further discussion. So as we reach a common understanding.
Okay, thank you, Alex. We come back. Let me take this first.
This is Qintang Xie from E3. I have a question about the slice. Does the slice include a set of physical resource, logical resource? A slice encompass the entire network or a subset of network? And what's the major difference in the concept of slicing and virtual network?
Who wants to take it? This is a professor answer, right?
So again, the slice question. So I think the slice is a set of physical resources at the beginning, the definition. But you could define a slice as a virtual network, but it's not just a virtual network. When you say virtual network, it's a logical network overlaid on top of the physical network, and we only talk about the network resources. But now, people talk about edge computing, and if the vertical is using the edge computing, for example, data caching, so then you have to consider a storage and a computation included in this slice idea. So it's a set of, so the first definition of slice was the set of physical resources and how you partition, allocate without interference with each other. So that's the concept that we had. But these days, the slice definition is changing, and if you have a better definition, you can go for it. But originally, I think it's a set of physical resources.
Caro?
A very quick add-on. I guess the origin of this kind of definition, which makes a lot of sense, by the way, is basically historical. And the reason is that the whole slicing thing started let's say from a core network perspective, and in a core network, resource is mainly related to transport, bandwidth, hardware, storage, and all these things. But if you start to move to the RAN and say it's end-to-end, you need to take into account the radio resources, the spectrum, the channels that you access, how to schedule, let's say, data transmission for the users and the access channels and all these things. And then it starts to get blurred, because then it would be good to efficiently utilize the spectrum for the different slices, instead of partition the band and say each of these sub-bands will operate in a given slice, and that's extremely inefficient in most of the cases. So this is why it changes a lot when you go to the radio.
Yeah, one question on business aspects of slicing. Slicing might be good for third parties who want to use the transport network, but is it always good for the owner of the transport network? I mean, he creates essentially also competition, because usually he's also owner of the access network, and then he allows other people to use the access network, and so what is the situation there?
This is for the operators, I think, and since I'm the only one representing an operator, I could say that up to now we have seen that over-the-top players are coming and utilizing our assets without allowing us to have any control. Now we can provide them the connectivity and we can provide them the slice that they want, but we keep the control. So we are not afraid of this. We are eager to give this back to the market, and we can offer slices, but we are controlling them.
So you will let them somehow get the quality of service, have more control on what they get,
Exactly.
but of course with the result that you can monetize on what you are offering them.
We can guarantee the quality of service and the quality of experience of the user. This is the big advantage that an operator have. I think most of you are using Skype. Have you seen that Skype is frozen in certain point of times? Could you consider using such a similar application with the perfect quality and the perfect experience without any interruption? This is only can be achievable if an operator can guarantee the quality of service.
Yeah. Yeah, I think it was touched also before. Another operator. Good.
Well, I guess operator has to join forces. But actually, I think this is all a very nice discussion. But linking back to the initial question about the difference between this and the virtual network, actually, initially, when I look at the slides, I also had the confusion. What's the difference between this and the VPN, that the good old VPN we had in the 90s? I think nothing popped out from vacuum. I mean, everything is kind of a continuum. Okay, in the VPN era, yes, like the professor said, the emphasis was the connectivity. It's basically a slice of connectivity provided by special business customers that operators would give. But in those days, the VPNs were not dynamically configured in a very fast manner. It's basically operators provision, configure, set it up. And yes, the business customer have some degree of freedom of modifying it slightly. But I think the idea of now the slicing in the 5G era, and I also like the statement that the slice is not a technology, okay? Slice is a concept. But enabled by the new approach with SDN, with NFV, not only the slicing 5G era involves, in addition to connectivity, also the storage and computation resources, and this resource eventually is a hardware, of course, physical, but it can appear to be virtual resources, virtual slice as well. But with SDN and NFV, and we are hoping that the reconfigurability and the autonomous control in the hands of the third-party user could be opened up somewhat without damaging our ultimate reliability, QoS, all of that SLA guarantees. But we do look for this approach to enable much broader openness and capability to new array of customer use. I don't know if I answered completely, but I think this is our view of. But I don't have a question, though. I have a question. Okay. Yes, it's nice in standard body when we attempt to put things very simple, okay? First, non-standalone. I go through eNode B with my NR to EPC. Ultimately, I want my new core to be the one basically cover all of the possible access. So of course it includes LTE or 4G plus or plus, which you don't like. All the access options, hopefully including the fixed line, all get unified with this one new generation core, okay? Now, my question is the transitioning, okay? Because you can talk about two endpoints is easy, but the transitioning, although of course is still in the work, but what is kind of the likely intermediate phases. In addition, even in your beginning phase, what kind of slicing capability do you expect the EPC will be tweaked to provide? My new red, okay, going through the B. And finally, when we have the new core, what happened to the EPC? It disappeared? It gets absorbed as a subset of the new core? Or what happened? That's my question.
And I will also add, if we have an evolution of the EPC, we will never get a new core.
Yes, we do. That's a new core, which is the evolution of EPC, right? But okay, I'm not getting into this. But about the EPC, I guess my slide didn't actually solve the problem or had a good answer for that, but was rather exactly asking the same question that you asked. What is the migration story in 3GPP? We have the EPC, we're going to have that solution. We envision a new core, connectivity for the new core. That's another solution. The question is, what happens in between? What's the migration story? And currently, let's say outside 3GPP, but somehow within the research community, there are rumors about these two approaches. That's why I was a bit surprised when I saw in your slide, Simone, like EPC, EVO, or New One, because this is somehow hidden between the lines. People don't talk about this as official views from anywhere. But it's very interesting.
This is why we are here today, right?
Yes, yes, yes. But it's very interesting. I guess we should rather focus on what are the functionalities of this new core. And this is what 3GPP is studying. What needs to be achieved by this new core? Then later on, what is going to be, how these NG2 and 3 interfaces are going to look like. And what needs to be achieved and what needs to change and so on. And then you look at the EPC and you think about, okay, EPC cannot really achieve this and so on. So there is really this gap. And then I think it's a valid question. I mean, like it is an evolution of EPC or is it a new one? And then what is not a good idea for sure is to have these two solutions hanging, I would say, and have these two parallel tracks. It's not good for the operators, it's not good for the vendors. So this is the dilemma that we have when we need to think about what this new core network looks like and what can we not achieve if this is an evolution of EPC and all these things. And yeah, it's a very tricky challenge that 3GPP needs to solve. I don't. Or I can't, it's being recorded.
Anybody wants to add? Otherwise, I'll take another question.
Another question. Just a short one. To be honest, remember the era between 3G and 4G. What was the transition? Totally new core, no risk, everything was migrated easily. Now things are simpler because virtualization is here today. Virtual machines are already running as EPCs. Why you are afraid? I'm not.
Stefan Kovaci from the Technical University Berlin. I also have a comment on, and at the same time a challenge to the panel regarding this discussion around the slices. If we accept that slicing is a business-driven concept, namely the environment in which a business relationship takes place between the provider and the consumer of this service, then wouldn't be it necessary at least to think about standardizing a kind of eastbound, westbound slice-to-slice interface in order to enable flexible value chains, and then also thinking about standardizing different categories of northbound interfaces for the slices. Otherwise, you will not fuel, let's say, future innovation also in what value chains regard. So in my opinion, in the end, you will see that we will end up that slicing will become also a technology and will be subject to be implemented by vendors which intend their products to be flexible enough to be stitched in order to create new value chains, new applications, new services. So I agree, it's a very good concept driven by business, but if we say A, then we have to say also B and think about what are the implications in creating value chains and what needs to be standardized. So I think that you need to include or think about including in the standardization work slice to slice or slice interoperability framework, and then you will have also technologies for that. What do you think?
Professor Nakao?
So this is a business-driven, question. So I'd love to hear other panelists would say, but I can tell you that in the research community, we already thought about this problem, multi-domain slice federation problem existed. So, and as I said in my slide, every country is trying to define their own 5G view. And if they define different type of slicing technologies, eventually how we connect these stitch slices together is a question. It's not just a business question. I'm not saying this is not a business question. This is a business question. But at the same time, how to realize this stitching is a great topic to work on from now on. And especially when, transport operator and a mobile operator, they may have different requirements for slicing. As Icaro said that, we have a radio concept in the slicing in the mobile network. So how we connect these already exists today. So I think, not only a business, but we, research community should carefully define how we stitch these slices together, especially when you have a different spec of resources and also different mechanism of slicing. I think it's a great topic for standardization.
Icaro?
Yeah, just a quick clarification from my side. When I mentioned that slicing is not a technology itself, there is a background. There is a lot of technology behind the things we would like to achieve with slicing. What I meant it was not a technology is partially because sometimes we hear, or I hear myself from some people, things like, if you want to split a network, you can do slicing. And this means nothing to me. I mean, how do you do the slicing is what matters. So in that sense, slicing is not an obvious technology. And this is why I also have as an assumption that slicing is not necessarily tied into NFV, SDN. Those are technologies that can be used in some context of slicing, for example, in the core network domain. But in the run, doesn't make so much sense. So this is what I meant. So, but of course, there are many, when it comes to technology, to achieve what we want to achieve in slicing, which is this business logical networks. Then there are of course some support in the standard that is needed, and this is being done today in SA2. For example, we started to talk about slice selection, maybe multi-slice UEs, things like this, or even inter-slice kind of communication. But it's still in a high-level discussion because people still need to understand what is the purpose of this and that. So there's going to be a lot of technology. It's just I needed to clarify that.
Yeah, slice is a concept. Then how you implement it is different. Yeah. Okay, since time unfortunately is running, so at a certain point we need to stop. Maybe let's take only the last point as a closing of the panel today. So it was related to what Kostas said at the beginning. So 5G is already today. So if you can just make your comment about this statement. So maybe Kostas, you take first, and then we go through the other.
I will start again. To be honest, this is not fair for the colleagues. But speaking about 5G, 5G has a variety of different use cases. If we are speaking about massive machine-type communication or enhanced mobile broadband, I could say that enhanced mobile broadband is something that will come soon. Massive-type communication is massive machine-type communication, massive IoT, is already today by using narrowband IoT and LTE Cat-M. It's here. The only thing is that in order to have the full-fledged 5G, we need also to integrate not only the wireless part, but also the wired part. Because we are speaking all this time about wireless and spectrums and all these things. Spectrums are not there for the time being. We have a long way to go, and this is a big story. On the other side, don't forget that the access layer will not only be wireless, but it will be also wired. So if we combine this and we see that gradually we will enter a new era that we will have some end-to-end slices serving a specific use case, like, let's say, waste management, like water metering, like automotive autonomous driving by using LTE for the time being and V2X in the future. I could say that from 2017 up to 2020, you will see the first slices of 5G to be in place. This is my point. Thank you.
Icaro?
Okay, 5G is today, first of all, because we all have LTE phones in our pockets. We use it every single day, and the LTE evolution is part of the 5G run story. So this is why 5G is today, at least that's one of the reasons, and that should tightly integrate with the new radio, which will address the use cases that LTE cannot address. And if you think 5G, we think immediately use cases, like everything is started with the METIS project. We talked about the use cases, this developed it further. And two of the main use cases, IoT, Internet of Things, vehicle to infrastructure and vehicle to vehicle communication. This is happening today in LTE, and very soon we will have things in the field in LTE, even before we standardize the new radio. So this is my short answer why 5G is today.
Alex?
Well, I have to agree that several things are taking place today, but based on the definition of the use cases, not everything is taking place today. So if we are discussing about 1 millisecond, no, it's not the case. And I have to agree that this is a matter of the different use cases. For some, we will reach them quite soon, but for others, it's a bit more complicated. And for example, that's my personal opinion. If we are discussing about autonomous driving, then there has to be some legislation and some regulation. So it's not only a matter of technology, it's also a matter of the business case and how the operators, the automotive industry will find, and the manufacturers or whoever else is going to be involved, they will have a realistic and attractive business case. So the technology is coming fast, but not in all the use cases with the same pace. And there are some other challenges that we have still to work on.
Professor Macau?
Okay, hard question.
Closing remarks?
So the 5G is today because we are forced to think that lots of, well, this is close to what Icaro already said, but we have IoT, devices already spread. You have to connect them all, and you have to use a mobile network technology to do that. And also on the other side, we have a content delivery, very different type of applications. And you have to accommodate very different applications in a single infrastructure. And we are forced to think what would be the ideal infrastructure to do all these end to end. So it's already started, so our thinking. My question is that when does 5G end? What's the definition of ending of 5G? If you achieve something, can we call it the end of the 5G? So you have to, define at some point, this is 5G and we are moving to 6G.
If we say that 5G will need to support the unknown use cases, then it's difficult to define when it is 5G ending. Yes.
Right. Yeah, that's my answer.
Okay, so I think unfortunately time is over. So I want to thank you very much, the panelists, and also your participation for the question and discussion. So thank you very much for the